Our next section is on weighted graphs and networks. Now, you guys so far have been working with graphs without any weightings on them. Okay, so let's have a look at this situation here. The edges of graphs represent connections between vertices. So you've got vertices over here and there's connections over here. So you could just imagine these being areas of a city, or suburbs in that whole area, and they've got weightings on them. So this 12 could represent 12 kilometers, a road between the two. So weightings have numbers like 7, 20, 8, 6 kilometers. They could represent, the length of the road. And these types of graphs are called weighted graphs. Okay, so that's just something for you guys to understand, that weighting means that there's numbers associated with the graphs. So weighted graphs in which these weights have physical quantities, these are quantities, distance, time, or costs are called also networks as well. Shortest path problems. So when we know numerical information about the connections traveling through a graph, you have extra considerations. Now, what happens is if the weights of the network represent time, you can choose a route that will allow us to travel in the shortest time. But how do you find that shortest time? How do you find that shortest distance if you want to? So that's called the shortest path. So from one vertex to another. So back in that previous question, if you're looking at the shortest path, you've got to use trial and error to try and find that shortest path out. So let's have a look at this in an example. So here, the example says, find the shortest path from Bartow to Kenton in this network here. Okay, so we're going to go from Bartow to Kenton. So that's our start and that's our finish. So we're going to start here and finish here, and we've got to find the shortest path. So we can go in many directions. So I can go 12 kilometers that way. So I can go like this. I can go like this, I can go like this. So there's several other ways to go. Or I can go this way, I can go this way, and this way. So you can see that I've got many options to go through all of this. So what is the shortest path though? How do I work it out? So there's a few ways you can do this, and one way is called trial and error. So if I was looking at this, I look, sometimes I just go like, if I want to start at Bartow here, for example, do I go 12 or do I go 7? No, I'll go 7 because that's a bit shorter. Now I've got 8 and I've got 9. So which one do I take? I might take 8. But if I take 8, I'm going to take 5 to get to Kenton, or I can go take 9 this way and then go and take 11 this way. So 11 and 9 gives me 20. I'll get 27 that way. So I think that's going to be the shortest path for me. So if I use BSOK, that there is going to give me 27 kilometers. So if I was looking at that, the others are going to give me more than 27 kilometers. So using trial and error, BSOK gives me 27 kilometers, and that's the shortest path. But then what do I do when I've got multiple edges and stuff like that? I've got to use a new system, a new way to do this, and there's something called Dijkstra's algorithm, which I'll explain to you in the next video.